Okay, so now we're looking at Exam 2, Spring 2018, Question 7. Question 7 says, I've got the sum from n equals 0 to infinity, cosine of n times pi all over n plus 1. Now remember, when I have the cosine, this is n is an integer now, the cosine of n times pi is going to be positive 1 or negative 1. So when I sum this out, when I actually start to enumerate, I'm going to get 1 all over 1. This is when n is equal to 0, minus 1 over 2, plus 1 over 3, minus 1 over 4, plus so on and so forth. So this series here, even though it has a cosine in it, is an awful lot like an alternating series. So we're going to do this test. Okay, this first part is telling us whether or not it's going to converge, okay, just as it is. Okay, so I'm going to do the alternating series test. The first part says I have to go the limit as n goes to infinity of 1 over n plus 1. Right, because remember, if I've got this minus 1, this is kind of like the sum of minus 1 to the n all over n plus 1. It's kind of like what we're looking at here. So if I do this as n goes to infinity, right, then this basically is equal to 0, which is good. My second test says 1 over n plus 1 has to be less than or equal to 1 over n plus 1. This is 1 over n plus 2, which is less than or equal to 1 over n plus 1. That's my second criteria for converging. So when it's an alternating series, this converges. Okay, this question asked, also, does it converge? Absolutely. So we have to check the absolute part. So in order to check the absolute part, I'm going to take the absolute value of it, which basically gets rid of this alternating bit, and equals 0 to infinity. So I basically have 1 over n plus 1. Okay, when I do this, I'm going to basically be doing a comparison test. Okay, I personally like the limit comparison. And the thing that I'm going to compare it to, the thing that's most closely to this is, I'm going to sum it up from, I'm going to actually start at 1 over n, right, because this is my highest degree term is for 1, like n to the 1, so that's what I'm going to compare it to here. Now this is our p series, right, and our p is equal to 1, which means that this diverges. This thing that I'm comparing it with diverges. Okay, so when I set this up as my limit comparison, I'm going to say limit as n goes to infinity, my series that I'm comparing, that I'm working with, all over the series that I'm comparing it to. Okay, when I do this, right, I'm going to get n over 1. So then basically this is equal to 1, right? On the limit comparison, having a 1 is good. This is a positive finite number. Okay, which means that the behavior of these two series are identical. Okay, it's positive finite, the behavior is the same, which means that this series is going to have the same behavior as that series. That means that this diverges. Okay, if it only converges when it's an alternating series, right, so it has the positive and the negative parts, and it diverges when it's always positive, that means we say, we do a general conclusion, is that this thing, this series, converges conditionally. Because it's conditional on it being alternating. The minute I get rid of the alternating part by taking the absolute value of it, it bombs out, it diverges. Okay? So the only way that it's going to converge is if it's an alternating series.